Hello friends, this is Vinayak from VB Education and this is a continuation lecture on our Java interview question series, and today we are going to see question number 5. The basic difference between the Java virtual machine, the Java runtime environment and just-in-time compiler. Also we'll see what do you understand by JDK. Now first of all, what is JVM, Java virtual machine? So Java virtual machine, basically it acts as a runtime engine to run Java applications. So if you want to execute a Java application on any machine, we should have JVM, Java virtual machine installed. Now JVM is one that is actually it calls the main method present in the Java code. So every Java code, it has a main method. So who is calling this main method? JVM is responsible for calling this main method. JVM is a part of JRE. So if we see in like in mathematics we have set and subset. So JVM we can call it as a subset of JRE. Now Java applications are called VORA, that is write once, run anywhere. What do you understand with this write once, run anywhere? So basically those who have worked on C, C++. So we know that a program written in C on Windows, it will not execute on the Linux environment. But if you have a Java program, we can execute it on the Windows as well as the Linux environment. Now basically what is the difference? How is it possible? Why we cannot run a C program on which we have created? Basically in C we create a exe file, right? Exe file or DLL files are created. So suppose exe file is created for Windows, then it cannot be executed on the Linux environment. But in Java we do not have an exe file. So basically in Java we have something known as bytecode, which the compiler is creating. So that bytecode can be executed on the Windows as well as the Mac operating system or Linux operating system or any other Solaris, any other systems. Okay, so we'll see that later. So this means that a programmer can develop Java code on one system and can expect it to run on any other Java enabled system without any adjustment. This is possible because of JVM. Now when we compile a .java file, what is .java file? Any Java file, that is source code, our source code. Whenever we write any code in Java, we store it as a .java file. So when we compile a Java file, when we compile a Java file, it gets converted to .class files, which contains bytecode with the same class names present in the .java file are generated by Java compiler. Means what? Suppose I have got animal.java file as my source code file. So when I compile this file, what the compiler will do? Compiler will create a animal.class file. So the name of the file is animal. See, animal.java, animal.class. So name will remain the same. Only the extension will differ from .java to .class. And this .class file, it will contain the bytecode. And this bytecode will be executed only if I have a JVM or JRE. That we'll see now. Okay. So this is the .class file. This .class file goes into various steps when we run it. These steps together describe the whole JVM. Now let's move on to the next slide. Okay, so from this slide it will be very much clear for you what do you understand by JDK. See here, if you see the JDK, it is a Java development kit. That means it is required for the developer to develop a Java code program. So if I want to create a Java program, I will require a Java development kit. Okay, if I have JDK, I can write a Java program on Notepad also. But normally people will prefer what? Eclipse. Why? Because Eclipse is an IDE. Okay, so it is an integrated development environment for writing the Java code. So it has IntelliSense. IntelliSense means it will, wherever there are some errors, it will show that in red line, underline. If you write a code in the text pad or Notepad, it will not show any errors. That is a syntactic or semantic errors will not be shown in the text file. But if we are writing a code in the IDE like Eclipse, then definitely it will show us what all errors are there, right? So mostly developers, they prefer to use the IDE like Eclipse. But here now today we are not learning Eclipse, so today we will focus ourselves to JDK. So what is JDK? JDK is a Java development kit which is essential for the Java developers. It contains the Java development tools. It also contains the compiler, which will convert this .java file to class file. So here we have animal.java file, and that will be converted by the compiler into animal.class file. So for compilation of the compilation of any .java file, we require only compiler. We do not require JRE or JVM. So we require JRE or JVM when we run the program. See, basically, if you go to any Eclipse or any other IDE, we have an option to build the project. So when we are building the project, that means we are trying to compile the code. So at the time of compilation, what will happen? Your .java file, it will get converted into .class file. Now I'm saying .java, .class. Let's try to understand what this .java and .class means. So I will move on to the next slide. So here, suppose I am using suppose I am using a Java language, that is my higher level language for coding. So here I am creating a class in Java. So class animal, curly braces open. Okay, so public static void main, only one method is there, and only one statement, sys out statement, animal class. Okay, so this class will print animal class. When we run this code, it will simply print the animal class. Now this particular file, it is having extension .java, and it is readable by human beings, right? Now what the compiler will do, the compiler, Java compiler, when you build the project, the Java compiler will convert this file into a file which is not readable by human beings. Okay, and that file is known as bytecode, right? So now a new file is created from animal.java. We have created animal.class file, which is not readable by the human beings, but it is easy for the system to understand, right? But it is not even understandable by the operating system yet. It's not completely understandable by operating system, because operating system understands only machine language, that is ones and zeros. So this is, we can call intermediate language. Okay, so that is a bytecode. Now what happens when you install JRE and JVM on any machine, and when this particular file, it is executed, then what the Java interpreter will do? There is something called interpreter. So the Java interpreter will read this code or this file line by line conversion. It will convert it into machine language, that is ones and zeros. So if I move back to the previous slide, here you can see this animal.class file in the it is given to the JRE at runtime along with other files and set of libraries. What the JVM will do, it will convert it into the machine code, that is ones and zeros. So input to JVM is the animal class file, other files and set of some libraries, and the output is the machine code, that is ones and zeros. Again you can see this small JIT, just in time compiler. So sometimes what happens, a same piece of code is repeated many times. Suppose we are calling a function n number of times, or we have any loop or something is there in a code which is again and again running, right? So such kind of code, it will be identified by this JVM. Okay, and that code will be stored in the JIT, so that the compilation and the execution of the program becomes fast. So that is just in time compilation. Okay, and the execution here, it is happening line by line, so it is known as just in time. Clear? So here we see JRE contains JVM plus set of libraries plus other files. So JRE is JVM, set of libraries and other files, and JDK is what? JDK is JRE plus, we have got JRE plus development tools plus compiler, that is Java C. Clear? Okay, now we have something. Okay, first we'll go to the JVM. What is Java virtual machine? It is an abstract machine. In other words, it is a program software which takes Java bytecode and converts the bytecode line by line into machine understandable code. JVM Java virtual machine acts as a runtime engine to run Java applications. So JVM is one that actually calls the main method present in Java code. JVM is a part of JRE, Java runtime environment. Now JVM performs some particular types of operations. What are the operations performed by the JVM? Loading of the code. So the loading of the code is done by the JVM. Verification of the code, executing the code, and it provides a runtime environment to the users. Now we have something known as class loader. It is a subsystem of JVM which is used to load class files. So as the name suggests, class loader, loading class. So it is used by the JVM to load class files. Its main responsibility is there. It has got three activities. That is, class loader. It has a subsystem of JVM which is used to load class files. It is mainly responsible for three activities: loading, linking, and initializing. Load the class file, linking the different class files, and initializing the objects. Okay, so all these functions take different forms of memory. So because there are various functions, so these various functions will take different forms of memory. So what is the memory structure of the JVM? The JVM has 5 different parts, that is parts in the memory. That is class or method area, the heap, the stack, the program counter register, and the native method stack. Now what is the class or method area? The class or method area is a memory block that stores the class code, variable code, that is static variable and runtime constants, method code, and the constructors of the Java program. So here method means the function which is written inside the class. It stores class level data for every class such as the runtime constant, pool, field, and method data, and the code for methods. Okay, then we have got the heap area. Heap area, almost every Java developer knows what is the heap area meant for. It is meant to store objects. So heap area is a memory block where objects are created or objects are stored. Heap memory allocates memory for class interfaces and arrays. Since array is an object, it is used to allocate memory to objects at runtime. Now what is the stack meant for? Third one is stack. The stack is meant for, so whenever we have, see, in a multi-threading environment we have multiple threads. So whenever there is a new thread which is created in Java program, that thread, it is allocated some stack memory. So each thread has a private JVM stack created at the time as the thread. It is used to store data and partial results which will be needed while returning value for method and performing dynamic linking. Java stack stores frames, and new frames is created every time at every invocation of the method. A frame is destroyed when its method invocation completes. So the frame is created and the execution is done, and the frame is destroyed when the method invocation is completed. Then we have got a program counter register. Program counter, as the name suggests, counter, it gives the memory location for the current part which is executed in the program. So each JVM thread that carries out the task of specific method has a program counter register associated with it. The non-native methods has a PC that stores the address of the available JVM instruction, whereas the native method, the value of the program counter is undefined. So PC register is capable of storing the return address of the native pointer on some specific platform. So basically what happens, suppose we are executing a Java code and at a certain point we are calling some method definition. So we have to keep track from at what point we were from the method has been called. So this can be done by the program counter. Okay, and finally we have got the native method stack. So like the stack, we have a native method stack. The native method stack, it stores the non-Java. It stores the non-Java. Also, let's see. It is called C stack. So native method stack are not written in Java language. This memory is allocated for the each thread when it's created, and it can be fixed or dynamic in nature. Okay friends, so that was all for today. So kindly subscribe my channel if you want to learn new things in Java, and also please give a like if you like the video. Thank you so much and see you next time. Bye.